Hi friends, welcome to the channel Learning R is Fun. In the last two videos we have covered probability distributions in general and how R deals with them. And we have also seen some specific examples in normal and Poisson distribution. In this video we will be covering statistical tests and in that specifically parametric tests. Now a statistical test is basically a decision making tool. And in this you take an assumption and you do a test and then try to find out whether your assumption is accepted, it may not be acceptable. While doing so, this hypothesis can be, you can say, one-sided or two-sided. An hypothesis will be generally a null hypothesis or alternate hypothesis. When you say null hypothesis, it is by default a situation which occurs. And an alternate hypothesis is that somebody proposes and then they have to prove it. We will take an example. Say the case of a plant growth is not affected by any specific color in the light. This is the hypothesis. This is not affected, no change, no effect. This is generally the null hypothesis. If somebody says a blue light makes a retarded growth of the plants, then they have to prove it. That is basically alternate hypothesis. So you have a null hypothesis and the opposite of that is the alternate hypothesis. Now when this kind of situation is there, the statistical test helps us to find out which can be accepted at what percentage of confidence. Now we'll see one example of a one-tailed hypothesis. Suppose we wanted to test whether or not girls on average score higher than 600 on SAT verbal section. In such cases, mu less than or equal to 600 is your null hypothesis. Mu is greater than 600 is the alternate hypothesis. In these cases, the portions shown in the red are the areas we are interested. Basically on either side of the tail. At least one tail only we are interested. On the other hand, if you look at the other example that mu is 500, that is the average of the SAT score is 500 and H1 is not 500. Not 500 means it may fall in this side on the right hand side of the bell shaped curve, in the right hand side tail or in the left hand side tail probability. So it is possible that we may find a result on either side. Now let us see what are parametric tests. Statistical procedures such as correlation, regression, t-test and analysis of variance, ANOVA in short, they assume certain characteristics about the population data, wherefrom this sample has been selected. They assume that the population data is normally distributed, that is they follow the normal distribution. The variances of the groups to be compared, that is through the statistical test, you are comparing, let us say, two groups. These variances are homogeneous or they are equal. And then the data is quantitative. The sample size is sufficiently large. Certain assumptions are taken. If these assumptions are taken, then you can say we are doing parametric tests, such as correlation, t-test, ANOVA, etc. They are parametric tests. Their validity depends based on the distribution of the data. That is their parameters. Whereas the non-parametric tests don't assume anything. We have got a table here. In this table we are seeing one sample t-test and two sample t-test, which is again parity test and unparity test. Then we have got more groups, then we have to go for analysis of variance and two-way analysis of variance, etc. All these things are parametric tests. And non-parametric tests are there where you don't make any assumption and then you do the test. Generally, the tests which you do through non-parametric tests, they are not as powerful as parametric tests. In this video, we will be doing t-tests, which are parametric tests, to get an idea of the statistical test. Remember, the scope here is just to say how R helps you to do a statistical test and generally what is a statistical test, to make an understanding to that extent. The statistics being a vast subject and tests are numerous, it will not be possible to cover all the tests, and that is not our intention. So in the RStudio, we will be just showing some examples. Now let's go to RStudio. For today's session, I have loaded 3 small programs. Our aim is to illustrate the use of t-distribution, that is t-statistics, and then how a t-test can be used for 1 sample as well as 2 samples. So we'll take a problem. This is given in the Verzani simple R. I have given the link. You can go through that text. He covers R in a nice fashion. And the problem is, suppose a car manufacturer claims a model gets 25 miles per gallon. But a consumer group asks 10 owners of this model to calculate their MPG, and the mean value was 22 with a standard deviation of 1.5. Now our question is the manufacturer's claim is supported? So in this case, since data is summarized and given, straight away we have to use the t-statistics and then find the probability. So x bar is 22 and the standard deviation 1.5 and n is 10. This is already given. So let us create these variables. Then we'll calculate the t-statistic, which is x bar minus the mean, true mean, divided by the standard deviation and divided by s by square root of n. So the t value we can find out. The t value is minus 6.3. For this t value, what is the probability? We can use the pxxx functions. That is for the distribution normal we use p norm. For t distribution we use pt. That's all. pt, t, and then we have to give the degrees of freedom. So we have found out the probability, that is 6.84 into 10 to the power minus 5, which is a very low value. Therefore we have to reject the null hypothesis. Null hypothesis is that that is the true mean is 25 or more, because the manufacturer's claim is that, and that is now rejected. Therefore true mean is less than 25. That's how you conclude using its simple t-distribution statistics. And let us take the second problem. Here we are going to take one sample t-test. Suppose a grocery store sells boxes of biscuits. A random sample of 9 boxes was taken and weighed. The weights are given in grams. You can see in statement number 14 we have got the weights. Now the company claims that the average weight of the box is at least 200 grams. Can you justify the claim of the manufacturer? So let us take the hypothesis, null hypothesis, that is it is at least 200, that is mean is greater than or equal to 200. Therefore the alternate hypothesis mu is less than 200. Now let us go ahead and execute the statements. Here the assumption is weight of the biscuits in a box is normally distributed, and we are going to test it at a 0.05 level of significance, that is 95% confidence. And let us first take the data values into a variable box weight using a concatenation function. X underscore bar, that is the mean of this, and standard deviation SD of box weight, and mu underscore 0, that is basically the population or the company's claim. We can say in general any box manufactured by the company should be at least 200. So therefore 200 grams, that is your mean, and samples we have taken is 9, so n is 9. Now let us calculate the t statistic instead of applying t dot test like last example. So now let us get the p value for the corresponding t using pt function. So we are getting a probability value very less. That means we cannot accept the null hypothesis. We have to reject it. That means the weight of the boxes are not 200, they are less than 200. The company's claim cannot be accepted. Now what we'll do, we'll simply tinker the values, or we'll just change the values. But before that, let's use the t-test straight away. And t-test and x, that is the data is box weight, and mu is 200. Alternative, here we give the particular method of test. We can give two-sided, less or greater. So here we are giving less because we want to check whether it is less than the 200 grams. So let us execute this t-test, and The t-test is also giving the same probability, that is 0.0002106, which otherwise also we got the same probability here, 0.0002105. Here it is 57, therefore it is shown as 6. So we do the simple t-dot test instead of calculating the values this way and then finding the probability. In both the cases we are very clearly rejecting the null hypothesis. Now I have just changed here 200, here also 200, 204. So I have given certain values of 200 and more. So the average definitely is going to be better than 200 or at least 200, closer to 200. With this box weight, let us find out what is the t-test telling me. The t-test is telling me the probability value is again 0.0002106, because box weight I have not updated. Sorry, I have to update the box weight. Okay, now we'll do the t-test. We are getting a different p-value, that is 0.15, which is more than 0.05. So we have to accept the null hypothesis. Null hypothesis, the box is weighing at least 200 grams. So that is how, when you get a simple one sample, how you can apply t-test and get a hypothesis verified. Now we'll go for another example. This is t-test examples 2.r. In this function we have got a problem. Two kinds of bumper guards, 6 each kind, were mounted on a certain make of compact car. Then each car was run into a concrete wall at 5 miles per hour, and following are the costs of the repairs in dollars. That means it is indirectly telling the amount of damage. The amount of damage is related to the design of the bumper guard. So we have to see whether these groups are going to be equal. They have the mean equal. It means both bumper guards are performing similar manner. These bumper guards are taken as a sample from a manufactured lot of say 1000 or something. Here also the same thing. So when you are verifying the sample means, you are actually verifying the population means. Okay, here at alpha is 0.01, that is 99% confidence he wants because it's a life-saving item. Whether or not there is a significant difference between the means of these samples. This is a question. Let's take the values B1, B2. Now let's test t-dot test B1, B2. Now paired is false. Here we can test t-test using a paired argument yes and no, that is true or false. When you say our same subjects are tested before and after a particular treatment, then we can say the paired test can be used. The same subjects are to be there in the first session and first sample as well as the second session, second set of values. Here we are having two different bumper guards. Since subjects are different, we cannot say paired is true. So paired is false. Confidence level we have taken as 0.99, and let's calculate the t-test. So we've done the t-test. Now R is going to give the results. R is performing a Welch 2-sample t-test. It has not performed a normal 2-sample t-test. It has performed a Welch test. So there is a significance why it is doing a Welch test. And now here the two p-value we are getting 0.6, which means we have to accept the null hypothesis. That means both these samples are both these designs are same. There is not big difference. Okay. Now suppose we have got another example where these values are not equal, they are different. Like we have got this problem. Suppose we wanted to test whether or not the average SAT score at Brown University was significantly different from the average SAT score at the Basmata University. Taking a random sample, the following 7 scores from students could be obtained. Actually here they could not obtain the equal number of values. In the sense, the number of participants in this experiment is only 7 in one case, in other case they could get more. So when these numbers are different, you can again apply the t-test. Only thing is, in the paired t-test you should have the same numbers. Okay, so let us take what is U1 and U2. And now let's go for the hypothesis, the u1 and u2 means when you find the difference it should be 0. The other alternate hypothesis is not 0, that means they are not equal, that's all. So in this case the variances in the original population assumption we can say is true, and then we can do it, and then we will say variances dot equal, that variance dot equal argument will say false and do. And let's see, in the second case Welch test is performed. So in the first case t-test is performed and it says p-value is 0.17, which is greater than 0.05. Therefore you have to accept the null hypothesis. That means the SAT scores are same for the both universities. Now this has been done with an assumption that variances across the SAT scores of the students in the respective universities are equal. If we don't have any such assumption, then what happens? So that is the performance by Welch test. In Welch test we are getting again the value is slightly different, but in any case it is greater than 0.05. Here also we find the university SAT scores are not different. So that is basically null hypothesis which we are accepting. We'll move on, we'll see one more problem. That is a city health department wishes to determine if the mean bacteria count per unit volume of water at a lake beach is within safety level of 200. The researchers collected 10 water samples and we have got the data. Does the data indicate that the bacteria count is within the safety level? That is, it should be less than or equal to 200. Test at alpha as 0.01, 99% confidence. Before we begin, let us formulate the hypothesis. We will say mu is less than or equal to, that is 200, that is within safety level. Mu is greater than 200 is no, it is not. So we will use the t-test, and here we will see the data as it is. We can use a concatenation function and supply to x, and mu is 200 because that is the safety limit, and here we have to give the alternative, that is this is where we would decide. Alternative in this case is greater than 200. So that is why the greater word is being used. You may be wondering whether how do I know it is greater or more or anything. You can always see the t-test the help. Here you see alternative. They have given 3 characteristics, two-sided, that is default. So you have to give either greater or less, otherwise two-sided will be the result. So we have to give greater. So that greater is what I have given here. Confidence level, of course, as per problem, it is 99%. So let's execute the t-test, and we are getting a value of p which is 0.8, which is definitely more than 0.05. We have to accept the null hypothesis. Null hypothesis is within safety level, that is less than or equal to. See, in reporting generally they say we fail to reject the null hypothesis. Why is it so? They can simply say we accept a null hypothesis. It is not the practice and convention. It is because generally null hypothesis is accepted as it is, and then somebody is trying to prove whether the null hypothesis is to be rejected and an alternate proposition is to be accepted. So a test is generally for rejecting a null hypothesis or accepting it. So accepting it is not the word. Instead we will say failing to reject is the preferred approach. So that's how you report. So now in these 3 examples we have understood how a t statistic is used. We have seen 1 sample test and 2 sample test. We have not used a pair t-test where you have to use the same subject before and after a particular treatment. Now say for example you give a drug and then control the BP. So what you do is you take the blood pressure of the subjects for a certain time, and then after the drug administration for the same subjects you do the blood pressure test and see the difference in the parity test. So that is not the case which we have done in the examples. Here we have done unpaired, but the usage of the statement is very simple. You have to only use the argument whether it is paired is false or true. So in these examples we have covered parametric tests. I have given certain examples how OR statement can be used in a simple manner to get the test done. Also, we have shown how the statistics is calculated, and then we calculate the probability, which is all encompassed in the simple test. So similarly, you can perform other parametric tests. Only thing is you have to understand the logic behind that and the assumptions. So in the next video, we'll be covering the non-parametric. Thanks for watching. See you in the next video.